We've looked at data types, conditional and iterative execution, and the formulation of methods to embody computational ideas. All of these programming concepts are at a relatively low level, and we're somehow meeting the computer kind of at its level in terms of how we compute things. Why not get the computer to meet us at our level? And we're going to do so by beginning a study of what are called objects. So far we'd like to represent the verbs of a program by methods, and now we're going to start to represent the nouns of our program designs by having objects. For example, let's suppose you have a robot object. You would like to direct the robot to turn 90 degrees. So we'll say robot, turn 90 degrees, pretty much in exactly that way. We want to create instances of related kinds of objects. Maybe we want not just one robot, but 5 different robots, each with a different purpose. Or we'll be using, throughout this particular area of study, account objects. And there should be more than one account in the world, maybe more than one account even for a given person. These objects are going to remember information about themselves. The methods we've been writing so far, when they're over and done with, don't remember a thing. But the objects we're going to create, for example, a robot may remember its position in the world. An account may remember the balance, how much money you have in your account. So objects are going to allow us to do this. Now, Java is an object-oriented language, but so far our introduction to this language has been more concerned with building basic skills, and now we're going to start to use what we know to design and instantiate these objects. We've actually already seen some objects in the work that we've done. Initially, we took a robot and did make it work its way through a maze. The robot was an example of an object. The colors that we studied, the colors that we used to represent red, blue, green, and so on, those are also objects. String, even though we studied string very early, it feels like it's something built into Java. It's actually also an object. The objects we'll be using mostly in the material we're about to study are an account object, because it's a very common kind of metaphor. We're all used to having bank accounts with balances. We say each account may have its own balance, may have its own interest rate. So at this point, as with recursion, you might ask yourself, well, do I really need objects? Can't I live without them? The answer is yes. You actually knew quite a while ago all you needed to write any program that could compute anything you want, but objects are a more meaningful way to express computation. For example, let's take the bank accounts. If you have 100 people, each with a different bank account, and they each have an interest rate and a balance, we could represent those as 2 different arrays. An array of 100 elements, each for their bank account balance, and another array of 100 elements, each for their interest rate. But these arrays are declared separately in the code, and they could float apart from each other. And how do we know they're being managed in a way so that the 100th person's account is really being reflected every time you access it? So we need a better organization that brings these account balances and interest rates together under one kind of a package, and that's what an object does for us. Also, these arrays are kind of open. I can access any index I want. I might accidentally spill money from one account into another by making an index error. I want to be able to control the access to this data so that an account balance changes only by depositing money and can't just change because some code decides it wants to change the value. So we'll be studying objects in this particular part of our course, building on what we know already, but architecting these data types that serve other purposes for us.